All right, folks, we're going to do something a little bit different this time. Rather than doing a PowerPoint, we are going to be, I'm going to run this the same way that I do my 7th grade notes, which is I have the same exact thing you do, and that way there's no questions as far as what you should write down and shouldn't write down, because there's been some issues with that where I will have examples done and you will have just the answer written, and that's not going to help you on the homework. Did you not get this? Did you want this? Did you want the notes? Okay. Did anybody else not get the notes? How did I skip? And then I would like people who write fast. Who writes fast legibly? Can you also, well, let's see. Because we need people to help out. Can you turn behind you and grab Leedy's? So you got Papa, you got Leedy, you. Well, Sparrow can. Yeah, we've got enough, right? Because there's only 3 that are Avery. Well, there's people that are absent, but I'm talking people outside. People that are absent, they can make it up. Okay, so you're going to put your name up there. Today is the 11th. Today is the 11th, 2/11/15, only just over a month before the best Pi Day ever. Because it's going to be 3.141593652. Is that what it is? Because I think it's not. I think it's going to be in this class when the actual Pi moment happens. Pi, which is Pi Day. Pi Day is going to be April 14th. All right. Or not April, March. Okay. So here's what we're doing with this one. Here's what we're continuing with these solving equations. We're going to be solving equations in the form of x plus p equals q, and also px equals q for cases where p, q, and x are all different. So what we're going to be able to do is, let's make this a little bit thicker. And let's get this magnet off. There we go. Okay. I will be able to solve for variables using inverse operations. From an equation. So you're going to be able to solve for variables using inverse operations from an equation. Do you guys have any questions? Oh, you can come back in, Jacob. And you can come back in. We're doing equations like you guys did first quarter, by the way. Yeah. Some of them I'm going to be pretty lenient on, okay?
Wait, where is it?
Remember, birds of a feather flock together. Where did the variables go?
Oh, yeah, okay.
The variables can't disappear. Variables cannot disappear.
Is that multiplying or is that just...
Good question. That's a 4x times the quantity of 3x plus 12. Mm-hmm. Okay, there might not always. Well, remember, there's 2 people that have money there. One person's going to have a certain amount, and then the other person's going to have a multiple of that. Right. So he has D dimes and N nickels. So Bob has D N. You know what I mean? So if I had 1 quarter and 1 dime, and then you had like 10 dimes, I could add my 1 to yours. Yep. Yes. And can you toss out that, please? Toss it out. Okay. Thank you. Had to get people's tests done. So we have the vocabulary, which is an inverse operations. Now, what is an operation other than a game that's scary? Yeah.
I was going to say it's the opposite.
Right, it is the true. That is very correct. You are ahead of me, and that's awesome. But what's just an operation? Yeah. Yes, addition, subtraction, multiplication, okay, and division. Those are examples of operations. Or how about exponents, right? That's another one. Okay, exponential form. The order of operations. Inverse means the backwards of that. Okay, inverse means the backwards of that. So inverse operations. So the opposite of addition, subtraction, multiplication, and division to undo an expression, to put into... Is that too small? Can you guys see that okay? Miguel, if you want to move out to Sparrow's desk since you're the farthest one away, feel free. Now, one way to look at this is when you have an expression, something's happening to the variable, you're trying to undo that. You're trying to undo that, make that go away. Because if I'm standing, I'll do it visually here. If I'm standing if I'm standing here and I want to take 2 steps forward to end up at this spot, okay? Now I'm standing on this spot. How would I undo that to get back to where I was? Yeah? 2 steps backward, yeah. So if I added 2 steps, in order to get back to where I was, I'd have to subtract 2 steps, right? So addition, as we just talked about, what's the opposite of addition? Subtraction. Subtraction. I'm going to do this in a different color. Well, let's use black. Subtraction is the inverse. And if you are standing in a spot and you subtract 2 steps and you want to get back to where you were, what do you have to do? Add 2 steps. So the inverse of addition is, or subtraction is addition. And then if we multiply something, what is the inverse of the multiplication? Eminem? Division. And what do you think is the inverse of division? Yeah. Multiplication. So it says here, an equation is like a scale. It must be kept balanced. Whatever you do on one side of the equation, you have to do on the other side of the equation. So when we use the inverse operations, we undo the stuff to the variable, and that's what I said already. So in order to keep things balanced, you must do things to both sides, because doesn't this symbol here mean equal? Okay? Just think of this. This is the way that I told my 7th graders. You have a sibling, okay, whether you do or not. You have a sibling in this situation, okay? If one of the siblings, so here's you, okay, and here is your, we'll say, 14-year-old sibling, okay? Now, if your 14-year-old sibling were to get a random $10, okay, would that be fair if you didn't, or would at least you bring it up? Why did he or she get $10, right? So you would want to get $10 as well. Okay? I like to use that equal sign as being like, that's not fair. Why did they get this and I don't? Right? Whining. Okay? So that's just the idea of keeping everything equal, because if you don't have them equal, that's not going to be good. So we have an example here. J plus 3 equals 9. And I'm going to rewrite this so it's bigger, because we will have plenty of room. So I want you to rewrite it as well. J plus 3 equals 9. So you have to look at this and be like, okay, what's happening to the variable? What's happening to the variable, Mr. Leedy? What's happening to the variable? It's being okay, we're not there yet. I see where you're going. It's being added. What's being added to it, Skylar? The number 3 is being added. The number 3 is being added to the variable. So how are we going to make that not happen to the variable? We're going to use an inverse operation. And what's the inverse of plus 3? Sean? Yes, subtraction. And how much are we going to subtract by? Kobe, how many are we going to subtract by? 3. We're going to subtract by 3. But then the 9 on the other side of the equal sign is like, hey, you're taking 3 away. I want 3 taken away too. And you're like, fine, stop whining, 9. Okay. You guys know why 6 is afraid of 7, right?
Yeah.
No, it's actually because 7's a very, very mean person. That didn't go the way you thought it was going to be. Yes, ma'am. How can I help you? Would it be less loud in here? Just if you go out there quietly and close the door, that'd be okay. Would you like me to do it for you? Okay. Better? Good. Okay. All right, let's try that again, shall we? So what are we going to have next? And here's the thing about solving equations. You want to get the variable by itself, always. You want to get the variable by itself. And you want to show each and every step. Okay? Is it safe to say that this is also, is negative 3 equal to negative 3? Yes, negative 3 is equal to negative 3. So we can put that equal sign in between every step. So what do we have left? What is on the left side of the equal sign? Yeah. J, just J. Good. What is on the right side of the equation? Nikki? 6. So I'm going to do this. I'm going to circle that because that's the answer. Now here's the wonderful thing about algebra. We can plug that in there to make sure that it works. Remember last night's homework, we were plugging in possible answers for variables, right? So let's put this back in. I'm going to make it green because I want to, green means go and we're going to check it. So if I have 6, because I'm going to plug back in, J equals 6, so 6 plus 3 is 6 plus 3 equal 9? Yes. Okay, then we're good. We're good, so you should have that written, by the way. If I write it, you write it. Okay, 6 plus 3. We checked our work. I'm going to go ahead and be like, check it. So we checked ourselves so there's no wreckage. Okay? So you don't want to wreck oneself. Good, good, good. Now, I'm going to do this one with you again. I'm going to rewrite it because I'd like you to rewrite it. 7, a plus 4. Now, the variable's on the right side. Darn it, that changes everything, right? No, it doesn't change. It doesn't change anything because you equal awesome and awesome equals you, right? So you can go either way. Yes, ma'am. You could, but I'd be afraid that you guys wouldn't copy it down the right way. So yes. Is it going to be multiplication? Well, let's see. What's happening to the variable? Ms. Middleton, what's happening to it? Well, no, but let's first I want to see what's the first thought, because you are correct, and somebody over here said that same. I can't remember who it was. Yeah, Leedy also jumped ahead. You're correct, but the first thing, because in the next coming lessons, it's not going to be as obvious you need to subtract. What's the first thing you see? What's the first thing you think about? What's happening to the variable? And what is happening to the variable here? Like, as we look at it just like that. Yes. 4 is being added to it. Correct. 4 is being added to it. So we have to undo what's being done to the variable. So in order to get 4 to go away, plus 4 to go away, what do we need to do, Emily? Subtract 4. So that leaves just A over here, and we have 3 over here. A over there. Since these equations you are solving for a variable, you must have the variable equals blah at the end of it, okay? So I'm going to test this out. 3 plus 4. Yes. 7 does equal 7. Check. Good. 7 does equal 7. Yep, today only, 7 equals 7. That's right. Today only and tomorrow. What? Okay. I want you guys to do this one on your own. I'm going to give you 1 minute. And it's not a race. You should have plenty of time in a minute. No, they don't blank. That'd be good. Thanks. Remember to check your answer. Who's not used the Polyvision board that would like to in demonstration? You have not used it? Nobody used it today except for me. Just one time? And there's a couple times where I passed you up too. Here you go. Bring that up with you. So Brooke saw that 23 is being added to it. Go ahead and turn the stylus 180. There you go. Yep. She's subtracting 23 from both sides because it's an equal sign, so you have to be equal to both sides of the equation. And as she's finishing up with that, and then Brooke also, if you go off to the right, do the checking your answer as well. When you have the number 23, the integer 23, is that positive or negative? When I just say 23. It's positive, okay? It's a positive integer. The way that we say integers is when it's positive, we don't have to say positive 23. No, you just say 23. Okay? So if you have a positive integer and you want it to go away, you subtract that amount of integer. Good. So we have 23 plus 6 is 9. Good. Yeah. And you won't need to circle this guy, actually. Okay, that you're checking your work is good, but you won't need to circle that. How are we doing on this? Okay. Yeah? This is straight up algebra right here. You guys are in the big show. There we go. Now let's try it with some subtraction. So we have x minus 5 equals a sneeze coming on. Ooh. X minus 5 equals 11. Oh. Now, if you look in your notes on the other side of the page, you might already know it, but what does it say is the inverse of subtraction? It says addition is the inverse. And the reason I had you look back at that is because if you are curious about something, I expect you guys to look at your notes. This is beyond the time where you're just going to get it or not get it. Okay? You will need to look at this stuff to verify that you're following the right formulas, that you're following the right techniques, and you're not making any silly mistakes, because that's algebra. It's not arithmetic where it's like, I know how to do 6 times 7 every time, all right. And I know how to do 7 times 6. Okay, yes, 42, but this is algebra, and we need to remember how to do that, brah. Okay? So the inverse of this is going to be plus 5. So I have x on this side, 11 plus 5 is 16. Okay. Now let's check. 16 minus 5, does it equal 11? Yes, it does. Ew. 11 does equal 11. So this next one here, we're actually going to do this one wrong. Yep. How to know if you made a mistake. I want you to write that on there so when you're looking back at these notes, you're like, why did I do it wrong? It's because we're showing what it'll look like if you make a mistake. So I have 7 equals c minus 5. Now let's say that I got a bit confused and I thought that the inverse of subtracting 5 is going to be to subtract 5. Because what often happens is people will skip this step here, okay, and they'll just write down, they'll move that negative 5 to the other side. So I'm going to do minus 5 here, and I'm going to do minus 5 here. So the person thinks that it's just c left on this side. It's actually not. But they think that it's just c on that side, and 7 minus 5 is 2. See where my error was?
Yes.
This is the error that a lot of kids are going to make. Okay? So now I'm going to check my work because I don't want to get these wrong. I'm going to check my work. So I have 7 equals 2 minus 5. Does 7 equal negative 3? No. I know that I did it wrong. Okay? That's what happens. That's how you check your work. Salud. You guys have 10 minutes. Just let you know, okay? All right. So you see why it's important to check your work? Yes. This right here, this little, where are we at? This little mistake right there, okay, that will happen. But by checking your work, you can avoid mistakes like that, okay? You can avoid mistakes. Wait. What do you mean, wait? Don't you have it on one of them already? Oh, you. Oops, wrong button. That whole thing is wrong. That whole thing is wrong. Because 7 does not equal negative 3. Nor will it ever be negative 3. Yes, sir. Maybe when we're done with this. Actually, I'm interested. Can someone please tell me why we just did a wrong example? Chloe, I haven't heard from you yet today.
Some people will not look at their notes and they'll be like, okay, I did right without looking at it.
Yep.
And then they'll be like, okay, I did this right.
Yep.
Yeah.
Yep. Exactly. You're exactly correct. Did I talk to this class about when you do poorly on a homework assignment while I'm waiting for the others to finish up? Okay, before I forget about this, If there's an assignment that we check in class and you do very poorly, this is the expectation I have of you. You're going to come see me during activity, or you're going to come see me during 0 hour, or we're going to figure out a time where we can figure out how to make sure that you understand that. Because not understanding something in this class is not okay. All right? I don't see how you did on that until I enter those grades. So it might be the next day, depending on how much we have going on that week. It might be 4 or 5 days later. Okay? If you do poorly, there's 2 things you can do. 1, you keep a hold of that paper and you come and see me. 2, when you come up and see me, we'll get it out of the stack. Usually not right at the beginning of class. That's when I have all my 7th graders come in for help. If you come in about 15 minutes into activity, that's the best time to come in, and I can give you my undivided attention. Okay? But if you do poorly on something, you are expected to come see me. And I'm going to email all your parents about this and tell them that as well. Okay? Because I don't like to see doing poorly on an assignment a couple days before the test when I'm entering those and you didn't come and see me and say, I did this wrong. Let's figure this out. That's my job. Okay? R minus 4. R. What's a pirate's favorite letter?
R.
You might think it's R, but it's actually the C.
Oh.
Yep, that just happened. Yep. That's not an original joke. That's not OC. Like that one, though? I got a good old chuckle out of that when I first heard it. Yes?
Why did the pirates in there?
Why not?
Got lost at sea.
Nice. Got lost at sea. I like that one. So what's the first thing that we're going to look at when we see these? Yes, the variables on the left side again. What's the first thing I'm going to look at when I see this, Rebecca? What do I need to recognize? Okay, R. Yes. What about R? We've already done it 4 times. I've asked the students that. What's the first thing we need to recognize? It's something about R. Something about the variable. When you look at this question, or when you look at this this equation, what do you see? Yep, and how much a subtraction sign, then what else? What's the number after that subtraction sign? 4. So when you look at this, whenever you look at these, you want to ask yourself, what's happening to the variable? Okay? That's the response I was looking for. What's happening to the variable? Then you have to think to yourself, I need to undo this. Inverse operations. And Mandrew, what am I going to do to undo what's happening to the R? Good. Yep, we have to add 4 to both sides because it's being taken away from 4. We want to get R by itself. We have the inverse operation of minus 4, which is plus 4. 4 plus 2 is 6. Let's check our answer. We have 6 minus 4, 2 equals 2, and that checks out. Yes, ma'am. It doesn't matter what side the variable's on. We could have the variable on that other side too. It would be the same thing. R minus 4. We'd still do plus 4, plus 4. Okay? It doesn't matter what side it's on. Okay? Let's see here. Is that the last one? Good. So if I were to summarize, ooh. In summary, what's the major concept of this section? What's a major concept? Someone put it into your own words using English. Yeah. Okay, inverse operations. Inverse operations. Oh. Yeah, I thought I spelled that wrong. Inverse operations makes the variable be by itself. Thank you, sir. Inverse operations makes a variable by itself. I used to joke around saying that the variable is very asocial. Okay? The variable is very asocial. It wants to be by itself. Okay? And it just doesn't want things added to it, doesn't want things taken away from it. It says variables, I want to be by myself. You guys go on the other side of the equal sign, and I'll be fine with that. Okay? So that's the only, actually that's a pretty good enough summary with that, because I want to pass this out. Is there homework? What class is this? Yeah. No, you are in the wrong classroom, brother. What's that? That's Brad's. I can... Yeah, would you want to hold on to it? Thanks. I only gave you 2? I only gave you guys 2? And since we are on very close timing, thank you, sir. We are very close to the timing of other classes. You are expected to show all your work, so I don't suspect cheating. You are expected to show all of your work. And I'm still recording. Why'd you put that away? Why don't you start looking at it at least?